Welcome back, everybody. This time we're going to talk about scale. There's only about 10 slides. This is very brief. I just want to make sure that we're all using the same terminology and that we're on the same page. So, scale. Where's my cursor? Scale has taken on a bunch of different meanings depending on who's using the word and what we're talking about. Scale can refer to the amount of detail in a map, the spatial extent of the map, or the actual map scale itself. So what I mean by this is that a map can be described as fine scale or coarse scale depending on how much detail. So high resolution maps are called fine scale, coarse resolution maps are called coarse scaled. It can also have to do with the number of attributes, the temporal age, things like that. But so anyway, we have the amount of detail defining scale. We also have spatial extent, so we can talk about a project that's very large scale, that might cover a large area. It might be large and complex in nature, or have spatially large spatial distributions of teams working on them. We can also have very small scaled projects, and we're talking about the spatial extent, so plot size or things like that. But generally speaking, we're talking about map scale. And map scale is the ratio between the distance on a map and the same distance on the ground. So here's a map of the waterfront area, Mississippi River in Minneapolis. Here is an inset, so we're talking about a smaller area. Now let's pretend that these two maps are printed or set up at the exact same size. So let's say that each one on a piece of paper covers 6 by 6 inches. All right. The way we talk about map scale is we define this relationship or this ratio between a unit of measure on the map and then that same unit of measure on the ground. So one map unit, if we were to take an inch, might equal, and this is completely made up, 10,000 inches on the ground. Okay, whereas in this map, 1 inch on the map may equal 1 million inches on the ground because it's covering a bigger distance, right? So if we divide these, or actually look at that ratio, 1 divided by 10,000 versus 1 divided by 1 million, which one is the larger number? This one is, which means that this is the larger scale map. It's counterintuitive. It's a smaller spatial extent, but larger scale when we're talking about map scale. This is the smaller scale map. So I tend to really clarify when I'm talking about scale. I'll say make a larger extent map. Because it's awkward to say a larger map scale map. So I tend to throw the word extent in there just to be specific about what I'm talking about. But just so you know, that's how we come up with that, and it's maybe one of the easiest way to remember it. Other than just saying it's counterintuitive, when we talk about extent, a small spatial extent is a large map scale, and smaller map scale is a larger extent. Just to totally confuse us all. So how do we represent scale? There's 3 basic ways we can represent scale on a map. Graphically, which is a typical scale bar. Verbally, where we can say 1 inch equals whatever, and a representative fraction, which is this. I'm going to talk about each of them because I really would like you to avoid using verbal or representative fraction scales for the work you do in this class. There are definitely times that you're going to want to do this. The USGS uses these types of map or scales all the time, but for our purposes they don't make a lot of sense. So here's why. Verbal scales, 1 inch equals 1 mile. Some of the benefits are that it's a really easy way to express scale. The difficult thing is they're only true if you're viewing the map at the same size it was set up, i.e. it was printed, so that you're actually holding it. Without a ruler, it's really hard to measure actual distances. Representative fractions, they're unitless, so 1 unit on the map equals 24,000 units on the ground. Like I said, the USGS uses this kind of fraction a lot. They really only work for printed maps, and they're not appropriate for digital maps. Now, so for our maps, I really would prefer if you don't use them. It's super easy to insert. It's not like you need practice doing this. If you're making a formal map for a situation where this is expected or required, it's a very easy thing to do. And if you're going to do it, I'd recommend that you do it right. Use big, round numbers. No one's going to want to see you put a representative fraction on your map that looks gloppy like this. So keep them clean. Here's why we're not going to use them. So you set up a map on your computer and it looks beautiful, and you plop in a representative fraction where 1 inch on your map in ArcGIS equals 30 million units on the ground. That's great. So 1 to 30 million. Then I come into my office and I'm looking at your map on the screen and it says 1 to 30 million, but in fact, because my screen is only 5 inches wide, the scale is completely different. See, the scale on the map is now incorrect because I don't have a printed copy. I can't control the size that I'm looking at it, and now it's actually incorrect and should say something more like this. I take the map home, I'm grading in front of the fire, because this is how I roll at my house. Project your map on the screen, and now your map that says 1 to 30 million is completely wrong. It's probably more like 1 to 3 million because it's so big, and if I were to measure 1 inch up on the map, full screen, it's going to equal a very different number of units on the ground. And then just taking it one more ridiculous step further, when you're giving your TED Talk and you go and project your map, now we're talking a really big disparate change from what it was originally set up as. So I would recommend that you use these graphic scales. It's a line with a distance measurement on it. The great thing about this is that you can blow it up, shrink it, view your map at any scale or size you want to, and this thing travels with it. You need to be a little bit careful because with the projections and the way that we flatten maps onto a computer screen or a flat piece of paper, the scale is only true the same place that north is true, where there's no distortion on the map. We're going to talk about this a lot next week, starting next week, but the center of the map is the only place that the scale is going to be true. But it does give us a good estimation. So just to drive that point home, here's our United States map again on your computer, and you actually set up your map in layout view and you've got your 1 to 1,000 mile scale. I blow it up, but this tracks with it. It's the exact same scale. It doesn't matter what size I view it at, this remains true. So this is why I plug graphic scales for the kinds of maps that we're doing, and in this day and age when we're usually looking at things on a computer screen or something like that. But like I said, you're absolutely welcome to use representative fractions. Just make sure that you're making them nice and clean, and you might want to make the caveat that that scale is true when it is printed at the size that you're setting up your map at in ArcGIS, and that's a very easy thing to check. If you set it up at the traditional size, it's usually an 8.5 by 11 piece of paper, and that's it. If you have any questions, definitely let me know. Thank you.